Hey, it's Miss Miklos, and this is just going to be a quick review over the concepts that you guys are going to see on your test this week. So the first thing I want to go through, there's going to be some problems like this on the free response, where there's a graph that is already drawn for us, and all the coordinates should be pretty easy for us to see. And the four things we need to figure out are the y-intercept, the x-intercept, and the relative max and min. So the first thing I'm going to find here is the y-intercept. So I know the y-intercept is when the graph crosses the y-axis. So here it looks like it occurs at 0. So I'm going to write that as an ordered pair of 0, 0. I know that whenever we have a y-intercept, that automatically means that my x value is equal to 0. Our x-intercepts, it looks like it crosses here and here. So my x-intercepts are going to be 0, 0 again, and -2, 0. So notice my x-intercepts had y values that were 0. Now a relative min and a relative max, it doesn't necessarily mean that each problem will have both of those. In this case, since we have a parabola, I only have one point that looks like a relative extrema. This is a maximum because it's decreasing on both sides. So for my relative minimum, I'm going to write none because it doesn't look like we have one. Our relative max here is an ordered pair of -1, 4. So the two problems that are on the test like this are this simple. We just need to know what intercepts are and what maxes and mins are. Next concept I want to go through is end behavior. Remember, when we're looking at end behavior, we're looking at two things: the degree of the highest exponent and whether this is even or odd. So this time I would say it's even. And I'm also looking at the coefficient, which is an odd coefficient. So if you look back at our notes that we took the second day of this chapter, we came up with a whole reminder. If it's even and positive, this is what happens. If it's even and negative, this is what happens. And I also reminded you guys, if you ever forget what to do, I can always make an easier problem. So since this is to the fourth, I made it squared because those are both even. Y equals -x squared is something that we've graphed a lot, and that would just be a parabola down. So I can see that it's going to -infinity both to the left and to the right. If this had been positive, it would have been up in both directions. Even always means it's going in the same direction. If this had been odd, so x cubed, x to the fifth, the directions would be opposite. So positive and an odd exponent means to the left it would be negative, to the right it would be positive. If it is a negative and an odd, that means to the left it would be positive and to the right it would be negative. So go back through your notes. For most of you guys did a great job on this on our quiz, but make sure you guys know those and how to tell the difference. Okay, so here we have a quadratic function, and we are going to have to graph it and also say what is actually occurring here. So if I look at this graph, this +3 is telling me that I have a vertical shift up 3. Since nothing else has changed, I'm going to plot my vertex at 0, 3. I would go up 1 and over 1 in both directions and draw my U facing up. Some other things we will see, and I would expect you guys to know for the test. If I have values inside my squared, like the quantity x minus 1 squared, remember that is a horizontal shift, and we always move in the opposite direction. If we see a negative in front, we know that that is a reflection over the y-axis. Okay, in this problem, we have a function that's given to us and a 0 that's given. This is already set up for us on the test. So what we need to find all the zeros, the y-intercept, and do a graph. Now, the one thing I do want to point out, even though this is set up for us, since we did not have an x squared term, we had to put a 0 in. So I'm going to go ahead and use my synthetic division. 1 times 3 is 3. When I add those, I get 3. 3 times 3 is 9. When I add that, I get 2. 2 times 3 is 6, which is 0. Now, if I did not get a 0 here, that means that I made a mistake because it's given that 3 is a 0, so it should work. Whenever we write this, we always start 1 degree lower than our original problem. So since this was cubed, I'm going with squared. We've learned a bunch of different ways to solve quadratic functions. By far the easiest is if we can factor something. And this one, I know 2 and 1 multiply to be 2, add up to be 3. I'm going to set those factors equal to 0, so I get x equals negative 2, x equals negative 1. So my zeros are negative 2, negative 1, and 3. So on my graph, okay, there's 3, there's negative 1, there's negative 2. I know that our y-intercept is always the constant, so it's negative 6. So it's all the way down here. Now, I really don't care about our relative extrema here, but one thing I do know, since this is odd and positive, it is going to be going down to the left and up to the right. And I honestly do not care how far up this goes or where this goes. I just need to make sure that we're hitting all of these points. Now, I should have known that we would have 3 zeros because our degree of this function is 3. Our next set of problems are going to say find all zeros. That's all we need to do. Now, to be honest, I don't know how to solve this except for by using synthetic division. Now, right away, I know I should have 3 answers. Even if we have a double zero, we are going to list it twice. Now, my possible rational zeros are always the factors of my constant divided by the factors of my leading coefficient. So this time, I actually have it pretty easy because the only way I can multiply to get 19 is 1 and 19, and my leading coefficient is 1. So we only have 4 options to try. This would be similar to one that I would give you guys on the test because there's not a ton of ways to go wrong. So I'm just going to try 1. So as I'm working through this, just a reminder that I know that something is going to work if I end up getting 0 as my remainder. Okay, and as I'm working through this, it does not look like I'm getting 0. So what I'm going to do, I'm going to try negative 1. So I get negative 8, which is 8. 19. 19 times negative 1 is negative 19. I got 0, so it worked. So right away, I know that one of my answers is negative 1. This would be x squared minus 8x plus 19 equals 0. This is something that is not factorable because there's no factors of 19 that add up to be negative 8. So I'm going to use the quadratic formula, or you can use completing the square. It doesn't matter. Okay, those are my a, b, and c values. So I'm going to do x equals negative b. Yes, you need to have this memorized. Plus or minus the square root of b squared minus 4ac divided by 2 times a. So I get 8 plus or minus root negative 12 divided by 2. We know that the square root of negative 12 is 2i root 3, or we could write that as 2 root 3i. We could write it either way, it doesn't matter. The final thing I need to do is divide both of these by 2. So it becomes 4 plus or minus I root 3. Or we could write that as root 3i. It doesn't matter. And this is a good reminder that i's come in pairs, and also that I should have 3 different answers here. So negative 1 is an answer, 4 plus I root 3 is an answer, 4 minus I root 3 is another answer. On this problem, we're going to have to put it all together. So we're going to have to start by solving for the zeros. So I am going to go ahead and set up synthetic division. I'm not missing any terms. So those are all my coefficients. Now to find out our options, it's going to be -3, the factors of -3, divided by the factors of 4. So it's going to be 1 and 3 divided by 1, 2, and 4. So unfortunately this time, I am going to have a lot of fractions. Okay, because 1 divided by 1 is 1, 3 divided by 1 is 3, but then I have 1/2, 1/4, 3/2, and 3/4. Now, I don't know about you, I don't love fractions, so I'm going to try 1 to start off with. So once again, I just want to stress, I know I'm getting an answer when I get 0. So I am really happy here because I guessed right away. And believe it or not, I don't have the answers in front of me. So I'm going to go ahead and write this as 4x squared plus 7x, or I'm sorry, minus 7x plus 3 equals 0. At this point, I could go ahead and set this up and use quadratic formula, or I could see if we can factor it. So remember, a good way to test if we can factor is if the factor times of the constant, if the leading coefficient times the constant, in this case that'd be 12, are there factors of 12 that add up to be -7? And our answer is yes, so let's try this out. I am going to try 4x and x, and let's see, maybe try -3 and -1. Let's double check if I did inside outside. -4x minus 3x is -7x, which works. So I can set these both equal to 0. So I get x is 3/4, and here I get x is 1. So my zeros are 1, 1, and 3/4. My y-intercept is -3 because that is our constant. So if I'm graphing here, okay, there's -3. Now I know when I have this double zero concept that what is going to happen is going to bounce off the x-axis. It's not going to pass through. So looking at my leading term here, it's positive and it's odd. So that means it's going down to the left and up to the right. So I'm going to go ahead and draw it. It's going to go through and it's going to bounce off at 1 and not pass through. So this is what a double zero looks like. It bounces off. It doesn't cross through like we see here at 3/4. So what I would need to see on this problem is this graph, these zeros, and the y-intercept. So everything we've gone through so far has been everything that you guys will see on the free response. So this is all the stuff you guys need to know without your graphing calculator. And just an extra note, I don't know what the heck I was doing over here. The way that I graph this, I'm just going to erase some of this. Actually, it won't let me erase. But the thing I need to remember, let's just make that one, pretend that's 3/4. I think you guys get the hang of it. We know how to graph 1 and 3/4. The important thing I wanted to stress here is how it's going through and how it's bouncing. So, sorry, it's late. I'm not thinking. There we go. So, this is starting the portion where you can use your graphing calculator. So, the first one will be a simple function like this, and there will be questions where you might have to find the vertex and find the real zeros. Now, real zeros is important because that means it's only our x-intercepts. A vertex, we know, is a relative min or a relative max. So, if I look at this graph, I can tell we have a relative min down here. I can't actually see the ordered pair, but that's okay. In my graphing calculator, if I press second, trace, it's going to give me the calculate menu and I can choose relative min. If you guys need more practice on that, go ahead and watch the video I made on the graphing calculator. When we go through and do this, we end up getting a minimum of -2.5, -12.25. We would say that's a relative min because it's the lowest point, it's increasing on both sides. Now to find our zeros, okay, there's a maximum number of 2 real zeros, and I actually can see 2 zeros here. And if we look carefully, This one, I can actually even just see it. It looks like this one's at -1. I'm sorry, at +1, and this one's at -1, 2, 3, 4, 5, -6. Now, if I wanted to double check these, I could go ahead and go into that second trace menu, the calculate menu, and use the 0 function. And we worked a lot on that today in our game. Okay, this one's actually easier because I can actually visually see it's crossing at integers. So those would be my real zeros. This would be my vertex. Okay, so if I gave you that the zeros of a function were 3, -2, and 1, could you come up with the factors? So let me use my pen to write. I'm going to write f of x equals, and remember to find a factor, it is always x minus the 0. So I would do x minus 3, x minus -2, which becomes x plus 2, and x minus 1. Now, I personally think this is one everybody should get right because that's all we have to do. There's no more work involved. Now, what if they asked us instead of just factors to find the equation? The first thing I would have to do is actually write out the factors. So x minus 3, x plus 1, x minus 4. Next thing I'm going to do, I'm going to choose 2 of them, and it doesn't matter if I choose these 2 or these 2, to multiply together first. So I'm just going to go ahead and multiply these first 2 together. So I would get x squared plus x minus 3x, which is minus 2x minus 3 times x minus 4. Now I have to distribute again, so my x squared becomes x cubed minus 4x squared. I'll change colors for each one here. Negative 2x becomes negative 2x squared plus 8x. Probably the toughest thing is remembering the negatives. And then I have negative 3x plus 12. So now I need to combine my like terms. X cubed minus 6x squared plus 5x plus 12 would be our answer. So the key thing on this is making sure I know how to write the factors, and then it just becomes like Algebra 1 style multiplying. Make sure that we're taking our time and don't make little mistakes on this, like distributing negatives and things like that. So I just want to go through some vocabulary with you guys. Whenever it's asking for total zeros, I can always just look at the degree. One question on the test is that easy. So in this case, there are 3 total zeros. Now if it's asking me how many real zeros, I could go through and find this algebraically, synthetic division. Since this is the part with my graphing calculator though, I'm going to graph this function on my graphing calculator, and I'm going to just see how many times does it cross the x-axis. That would be the number of real zeros. So we might see real zeros, we might see x-intercepts. Those mean the same thing. It's important that we know what our terminology means and what it's asking for. So there is a problem with synthetic division, so I'm going to set up my row of coefficients. Since I'm missing an x, I need to put a 0 in. And the key thing for us to remember is our box number when we're actually dividing is always the opposite of whatever number is in our divisor. So I'm going to use 2. So I'm going to go through and use our synthetic division here. In this case, it's okay if I don't get 0 as my remainder. So I would write this as 2x squared plus 3x plus 6. Our remainder is 16, but the other way we might see it is 16 over x minus 2. There's also some problems that are just basic complex number issues. Here, all this is asking us to do is multiply. So I'm going to FOIL. So I would get 2 minus 2i plus 3i minus 3i squared. Now the important thing for us to remember is that I squared is equal to -1. So this actually becomes 2 minus 2i plus 3i minus 3 times -1. This becomes a positive 3, so 3 plus 2 is 5. When I add my i's together, I end up getting plus I. So 5 plus I would be our answer. There are some problems that are this basic. All I need to do is go ahead, multiply, add my like terms together, and remember that I squared is equal to -1. Here's another problem dealing with complex numbers. So this is just telling me to do subtraction, but the key thing is I need to distribute that negative. So this is actually 3 plus 2i minus 1 plus I. If I remember to distribute the negative, this is a really easy problem, and I would just get 2 plus 3i, and I'm done. I really hope we get these problems on the test right. On the multiple choice, this is worth just as much as doing a much more complicated problem. Make sure you remember all those little things. We've talked a lot about the term complex conjugate. Now this looks weird because I know I shouldn't have a number that looks like this. So first thing I'm going to do, I'm going to write this as root 2i or I root 2. It means the same thing. And now I can go ahead and write the complex conjugate. We said the complex conjugate, same two terms, change the sign in between. So I would get 4 minus root 2i as my answer. When I'm dividing by an I, there is a problem here because I know I represents a negative. So we said the way we can fix this is by multiplying by the complex conjugate. So in the numerator, I get 1 minus 2i. In the denominator, when I FOIL, I get 1 minus 2i plus 2i minus 4i squared. So I end up just getting 5, and the reason why, these terms cancel out. I know negative 4i squared is like plus 4, so 1 plus 4 is 5. Now I'm going to have to split this up to be 1/5 minus 2/5 I, and that would be our final answer. Now, if you guys got to here, you'll be in good shape because since this would be a multiple choice question, the options would look split up, so that would be a good reminder that you actually had to do that. I wanted to go through one where we had to deal with some imaginary zeros because I know we went through one in class today and we all disliked doing it because we felt like it was kind of a waste of time, but that's okay. So first thing I'm doing, I'm writing out all my factors. So once again, a factor is always x minus whatever the 0 is. I'm going to group this together. So I'm going to multiply these two, and I'm going to multiply the terms with the i's. Always multiply the i's together because it will cancel out. So my first multiplication here, I get x squared plus 2x minus 1x, which is just plus x, minus 2. My second group over here, I get x squared plus ix minus ix minus I squared. Oh, that looks weird, huh? There we go. Minus I squared. Now, those cancel out. So I actually have x squared plus x minus 2 times x squared plus 1. Negative I squared is equal to a positive 1. Now I can just multiply all these terms together. So once again, this isn't necessarily a difficult problem, but it can take a little bit of time. So I would get x to the 4th plus x squared plus x cubed plus x minus 2x squared minus 2. So all I did, I distributed x squared, distributed x, distributed negative 2. Now I can just add my like terms together. So x to the 4th plus x cubed minus x squared plus x minus 2. And that would be our final answer. Last concept I want to go through on this review is a problem where it already gives me the equation and it already gives me 1, 0. So I'm going to begin by setting up synthetic division. And I'll let you know that this is the level of difficulty that it will be on the test. So 3i is my answer. Now, a really nice thing, I know I should get 0 here. Also, I know if 3i is a 0, negative 3i is also a 0 because we learned i's come in conjugate pairs. So I'm going through this process. 1 plus 3i, I can't actually combine that, so I just write 1 plus 3i. So now let's think. 3i times 1 is 3i. 3i times 3i is 9i squared, which we learned is negative 9. So I just get 3i. 3i times 3i once again is 9i squared, which is negative 9, which gives me 0. Now this looks really gross with all these i's in here, so I'm going to go through this again and use negative 3i. This time, when I go through the process, it becomes a lot easier. And this was x squared, this was x cubed, this is x squared, so this is just x. So I get x plus 1 equals 0, so x equals negative 1. So my answers are plus or minus 3i and negative 1. So hopefully this kind of just quickly reviewed all the concepts that you guys need to know for your test. The better you know how to use your calculator, the better off you will be. Practice finding zeros in your calculator. Okay, I hope this was helpful and good luck on the test.